Okay, so our goal for this section really is how do we find these dotted lines? That is the important thing, that one of the important things that we want to do. So first we'll work with the vertical asymptotes. So to find them, there's really two steps. The first one is you want to factor the numerator and the denominator completely. Okay, and once you factor, you want to cancel any like factors. And I'll give you some examples here in a second. And then number two, what we want to do is we're going to be setting the denominator equal to 0, kind of like the way we found the domain. But first we have to cancel any like terms. And solve for the variable. Okay, so those are our two steps. So let me do an example with those two steps. So it says find the vertical asymptote, if any, for each graph. So the first thing is to factor the numerator. So here, x is already factored, but x squared minus 1, we can factor as x minus 1, x plus 1. And then you want to ask yourself, can you cancel anything here? And we can't. The only time you can cancel something is if we had, for example, something like this, then we would be able to cancel the x plus 1. But in this example, we only have x up here, so we cannot cancel. So it's already done for us there. So step 2, set the denominator equal to 0. So set denominator equal to 0. So we're going to have x minus 1, x plus 1 equal to 0. And you want to solve for x. So for this one, we get x equals -1, and for this side, we get x equals 1. So these two are going to be our vertical asymptotes. And so when later we're going to need to graph this, to graph it, you would just come to the graph, and at x equals 1, you're going to draw it with a dotted line, and at x equals -1, we would draw it with a dotted line as well. Okay, any questions on that one? Okay, so if we go to B, we make sure that it's factored already. So x minus 1 is factored, but x squared minus 1, we can factor it as x minus 1, x plus 1. And then we ask ourselves, can we cancel any like terms? So here, I can cancel this term. Okay, and so I'm left with, after canceling, I'm left with g of x is equal to 1 over x plus 1. Okay, so now we can set the denominator equal to 0. So x is equal to -1. This is your vertical asymptote. Okay, so again, the first step is factor completely, which I did here. Second step, or it's still part of the first step, cancel any like terms, which I did here. And then the second step is set the denominator equal to 0. And so we get x equals -1. That's a vertical asymptote. Now, anytime that you can cancel a factor, what we say is that it creates a Let me write it here. Okay, it creates a hole in the graph. And what I mean by that is if I had a graph, for example, and I have my graph like this, it's that open circle, that's gonna be the hole. And so you only get one of those if you cancel a term. And so the way we're gonna find it, let me write the instructions here. Okay, so to find the hole, we're going to set the canceled factor. Set the canceled factor equal to 0. And solve for x. So in this example, our canceled factor was x minus 1. So I'm going to set it equal to 0. So this is where the hole appears. Okay? But we want to know the exact location on the graph, so we need to find out, since we already know what x is, we need to find out what y is. So to find y, I'm going to come here. Let me just come over here on this side. So to find y, we take our function after we canceled the factors. So remember up here, this is what we have had left. So we plug it in here as our function. And since x is equal to 1, we're going to substitute the 1 for x. So we get a half. So the hole is going to be at 1.5. So whenever you draw your graph, for example, here's 1 and here's a half. The graph would have a open circle at that point. Okay, so the next example is also gonna give us a chance to practice finding that hole if it has one. Any questions on this example? Okay, so let's look at letter C. And if you notice, letter C and D is the same example. So I'm just gonna work out the C one over here. And so again, the first thing is we're looking for a vertical asymptote. And so I need to factor this vertical asymptote. Does it factor? So x squared plus 1 is not going to factor. So this is already set. So if we go x squared plus 1 is equal to 0, and I take the square root, I end up with an imaginary solution. And so whenever that happens, we say that there's no horizontal asymptote. Okay. But let me give you one where we can practice finding everything else again. So this is an extra example that's not in your notebook. Okay, so let's say we have f of x is equal to x squared minus 4 divided by x minus 2. So the first step is to factor this completely. So the top part is going to factor as x minus 2, x plus 2. So that is how the numerator factors. And then the denominator is already factored. And can I cancel out any terms? And if so, what can I cancel out? Anybody want to share what they think?
I have no idea.
So which ones are common? So the x minus 2 and the x minus 2, they're the same, right?
Mm-hmm.
So those we can cancel. And so what we have left is going to be x plus 2 on the numerator And on the denominator, there's nothing left, so there's only a 1. So our new function here is x plus 2. So after we cancel, the next step was set your denominator equal to 0, but there's no more denominator here. Notice how the denominator is not there anymore. Like in these examples, after we canceled, we were still left with a denominator, but on this one, there's no denominator. So what that means is that there's no vertical asymptote because we have no denominator left, okay? However, since you were able to cancel this term here, then there exists a hole in the graph. Okay, and so to find it, we do the following. Number 1, set the denominator, set the cancel term equal to 0. So our cancel term here was the one that we scratched out over here. That's x minus 2 is equal to 0. So if I solve for x, I get x equals 2. But then we need to find a y for that. Okay, so to find the y, we're going to plug it into what we have left after we canceled the terms. So we're going to plug it into f of x equals x plus 2. So what this means is that there's a hole located at 2, 4. So on the exam, I don't believe that the questions that I selected don't ask you to find the hole. But in case it did, this is what the steps would be. But if I remember correctly, I didn't choose any that asked you to do that. So that is how we find the vertical asymptote. Now we want to find the horizontal asymptote. So let me go to the handout. To find the horizontal one, it has 3 different cases or situations that could occur. So the first one is if the degree of the numerator and we're going to call this n for numerator, is less than the degree of the denominator, and let's call that m, then there is a horizontal asymptote at y equals 0, which is the x-axis. Okay, so this is what I mean by this statement. Let's say you have a function f of x, and you have x plus 1 divided by x squared plus 2. Okay. To find the horizontal asymptote, we need to look at the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then it's going to automatically have an asymptote at y equals 0. So the degree of x here is 1, and the degree of x here is 2. So the degree here of the numerator is 1, and the degree of denominator is 2, okay? So the top one is smaller than the bottom one. So the numerator is smaller than the degree of the denominator. So automatically we say that this problem will have a horizontal asymptote at y equals 0. And that's going to happen all the time. So for example, if you had f of x equals x cubed minus 3 divided by x to the 4th plus x squared plus x plus 8, something like this. If you want to find the degree of the horizontal asymptotes, we have to check the degrees here. Well, the numerator is smaller than the denominator, okay? So if that's the case, then we say that there's a horizontal asymptote at y equals 0. And it's always going to be y equals 0 if this is smaller than this one, okay? And we'll do some examples right now. The second case is when they're equal. If degree of numerator equals degree of denominator. Okay, if that happens, then the line y equals the leading coefficient of numerator divided by leading coefficient of denominator. So let me tell you what I mean by that. That's going to be your horizontal asymptote. So for example, if I had f of x is equal to 3x divided by x plus 4, we check the degrees. So this degree is a 1 and this degree is a 1. So the degree is the same, okay? So degree is the same. If that happens, then to find your horizontal asymptote, we would do the following. We would say y is going to be equal to the leading coefficient of the numerator. In this case, it's going to be 3, divided by the leading coefficient of the denominator. In this case, it's going to be 1. So y equals 3 would be your horizontal asymptote. And I'm going to give you another example. That way you can try it. Let's say we have 4x squared divided by 5x squared minus 8. Okay. So first, ask yourself to look at the degrees. So the degree here is a 2 and a 2. So they are the same. So that's going to be option number 2. If the degrees are the same, then the horizontal asymptote is y equals the leading coefficient divided by the leading coefficient. So in this case, they're the same. So y is going to be equal to the leading coefficient of my numerator here is 4 divided by my leading coefficient of my denominator, which is 5. So this is going to be my horizontal asymptote. So when you draw your graph, for fifths, you would draw a dotted line that is a horizontal line. Okay, so that is the second case. The third case is if the degree of numerator is greater than degree of denominator, then what we're going to have is that there is no horizontal asymptote. Okay. So the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. For example, if I had f of x is equal to 3x squared divided by x plus 1 My degree here is a 2, and this one has a 1. So the degree of the numerator is greater than the degree of the denominator. So my answer here is there's no horizontal asymptote. Okay. And then we add to that statement here. So if there's no horizontal, then there might exist a slant asymptote. And the way we know if there's a slant asymptote is as follows. If the degree of numerator is 1 more than degree of denominator, then that's how you know if it's going to have a slant asymptote.